if they're
All right. So, hi everyone. I hope everyone is doing great. Welcome to this class for our CCNA batch, where I'm going to talk about OSI model, and we will be discussing how the physical layer works. Okay. So I'm just going to share my screen. Just give me a minute, and I will give you the ability to unmute yourselves as well in a few minutes. Don't worry. So let me know if you can hear me and if you can see my screen. Can you see my screen? Okay, great. Awesome. And is the audio loud and clear? All right, cool. So can anyone tell me what did we talk about in the last class? Yes, I've given you the ability to unmute yourselves. Just want a quick summary of what we discussed in the last session. Anyone?
Hello, sir. Sir, myself is 𝐊𝐲𝐬𝐬, sir. Actually, I'm new in this class, sir. How many classes? Actually, I was in another class. That's the reason, sir.
Okay, so we just had one session before, okay, where
Okay.
talked about what networking is. Don't worry, we will.
Okay.
If you
Thank
missed
you.
out
Thank you,
on
sir.
that portion, I'll cover that again.
Okay, sir.
Yeah, no problem. Yes, Surajna. Yes.
Hi, sir. This is Rajna. Actually, in the last class, we just talked about the introduction to networks, and then we covered the network criteria, which is very important factor for to be considered before selecting a network. And then we just spoke just introduction to OSI. Introduction to the network models. And today you said that you will discuss the OSI model. That's it, sir.
Right. And what were
Thank you.
those two factors?
The factors are performance and reliability and security, sir.
Okay,
Which
great.
the factors we need to keep, which we need to check before selecting any network.
Right. And in security, there are three more factors. And what are those?
Those are confidentiality, integrity, and availability.
Right. Thank you. Thanks a lot. Thank you.
Thank you.
Yep. All right. So we are going to talk about the OSI model. As you all know, OSI model is Open Systems Interconnection Model, and it has been created by whom? It has been created by an organization that deals with standardization. Okay, and the name of that organization is ISO. So some of you will be complete beginners. You are recent graduates. Some of you are working in organizations. So I don't know if you know about what risk management is, what governance is, but yes, in your organization at very high levels, okay, at management levels, senior management levels, they will talk about ISO related standards, not OSI, but other standards. So ISO is a very big name. Okay. So throughout your life, you will work with standards from ISO, okay, International Standards Organization. Okay, so there are 7 layers in this model, all right? So 3 of them will be focused on extensively in this course, okay? But actually 2 of them will be focused on way too much in detail. And which are those layers? Data link and network layer. Obviously, we are going to work on other layers as well. We are going to discuss concepts and protocols that will work on other layers. But when it comes to data link and network layer, they are really important, especially for CCNA, especially for L1 network engineers. Okay. So data link layer is where you'll be working with a device called a switch, and network layer is where you will be working with a device called a router. And it's completely fine if you don't know, okay, if you don't know what a router is or a switch is. I'll be explaining everything from scratch, okay? So all you need to know to get started with today's class is the description of a network. So what is a network? A network is a collection of devices which will talk to each other through a medium, okay? Now that medium could be a wire, which means a cable, or a wireless medium, like through Wi-Fi or through Bluetooth, right? And in a network, you require a networking device. So this is something that I believe everyone knows. So we are going to start with the OSI model today. So the first 3 layers. Now, a lot of people are confused about how do we start discussing this model? Should we start with the top to bottom approach, or should we follow a bottom up approach? So the OSI model is understood through bottom up approach. Okay. Now the first layer is known as the physical layer. After that, you have data link layer, and above that, you have network layer. So these 3 layers, right? These 3 layers work in collaboration with each other, right? And they are also known as the hardware layers. What are they known as? They are known as the hardware layers. Above network layer, you've got a layer known as transport layer. We also call it heart of the OSI model. And basically this layer connects the layers above it with the layers below it, which means that it is going to connect software layers and the hardware layers together. Now, how will it exactly do that? We'll talk about it. Then above transport layer, you've got session layer, presentation layer, and application layer. Okay, so these are known as software layers. So after completing CCNA, you will be well versed. You will become well versed with what happens in the network layer. You'll be able to make configurations. You will be able to troubleshoot the configurations. You'll be able to maintain those configurations. And the same goes for data links here, right? So when it comes to physical layer, earlier in CCNA, what used to happen? They used to talk a lot. They used to teach a lot about cables, right? So this is when CCNA was being delivered in person. Now after COVID, CCNA almost everywhere is being delivered online. So we will talk about cables. We will talk about their use. How are fiber cables different from copper cables? What is Ethernet? We are going to talk about all of that. Okay. But that is what you should not focus on a lot. You will understand those concepts, but your line of work is not related to physical layer. Okay, let me tell you straight away. because a lot of students are confused when they start CCNA. They ask me, hey, in the previous version that was 200.125, they used to teach us how to crimp wires, how to crimp the cables. They used to tell us what TIA 568A is, what 568B is. Now, in CCNA 200301, they are not focusing too much on cables because that is the work of network technicians, and you can also call them field engineers. Understood? You as network engineers will work on these two layers, network layer and data link layer. So I know some of you are still confused, like, what is this guy even talking about? So let me start. Okay, let me start from scratch. So we'll start with physical layer. Okay. Now, what exactly happens at the physical layer? What can I include in the physical layer? Yes, let me unmute you. What kind of devices will I include in physical layer?
Ethernet cable.
Okay,
Cable, fiber cables.
all right.
And
What
ICs.
So
Wi-Fi.
cables, connectors, signal options of mediums, all the hardware things are present in the not only hardware, just like cables and connectors are present in the physical layer, sir.
Okay, what about
Sir,
hardware? What about devices?
Repeater and hub.
I can tell you, like SDH, we can connect SDH router which has functionality which SDH and or SDH component like email, XMP1 LCC or other devices. We can connect something like with optical fiber, or we can connect non-managed switches with LAN cables.
Right, right.
Or
So I
with
guess everyone,
PCs.
right, right. Everyone is right. All of your answers are right. So basically, when you go to a server room, you're going to find devices there. Okay, you will even find routers and switches, but those devices are just present in the room. Okay, they are not actually working in those layers. So you will see a router and a switch physically being present in the location, right? In that particular location, in that particular server room, but they are not working in that layer. So basically, when you talk about physical layer, it's the groundmost layer. And here, what will you have? You will have devices arranged in a particular manner, right? And what do we focus on here? We focus on how they are arranged, what kind of cabling they are using, and how they are working. Okay. So here, if I say that machines are present, would that answer be right? Machines are present. And there are different signals. Is that a right thing to say? Yes. Yeah, you can unmute yourselves. What do you think?
Signals, yes, sir. There is a machine to handle these all situations, sir.
Okay.
Communication and data transmission.
All right. So anyone else who would like to give their opinion?
There is a device called repeater, which enhances the signal, sir, in this layer, physical layer.
Okay. All right. So, but when you visit a server room, right, or when you visit your data centers, they will have devices, arranged in a particular format, arranged in a topology. So physically, all of those devices are present, right? Physically, in that server room, all of the devices are present. Now, when we talk about physical layer, we don't include router or switches, right? We don't include routers or switches. We usually talk about repeaters. We usually talk about, repeaters, right? So basically, in this layer, transmission of signals is happening. Is that right? Is that correct? Okay. And what kind of signals are there? So you have two types of signals. One is a digital signal, right? And the other one is what? An analog signal. So we've got two types of signals. One is your digital signal. And the other one is your analog signal. So yeah, what is included in analog signals? Electrical signals, what else?
Sir, we can add devices like transducer, which can convert analog signal into digital, and then we can convert this
Yep.
signal into digital data.
Right, that you're right. But my
Sir,
question
what
is
about light as a signal, sir?
light signals. So yeah, that's my question. Are light signals digital signals or analog signals?
Sir, we can convert
Analog
light
signal.
signal into digital and optical signal by devices like SDH. We have to use
Sir, I think light is analog.
That's my question. What is you're completely right, Sriram, that
we
It
convert
can be
the
both.
signal.
it can be
It can
both.
be both.
When would it be digital? That's my question.
Sir, sir, actually, I'm working on this field, and we convert this electrical signal into optical by cross connection using devices like SGH or PDH.
I
Media
get
converters,
Heritage devices.
I get that, but should I include light signals in digital or in analog? That's my question. You can convert them, I understand that.
Sir, they take only digital data,
What, light signals?
light signals,
But
0
light,
and 1s.
It can carry both analog and electrical and analog data. Digital is basically when there is a 1 and 0.
okay, zeros and ones.
Yes.
And digital is zeros and ones. Everyone is aware of that. And what about light? Because in light, what
It's
kind
an
of light
analog,
can draw?
analog
It's-
signal. It can
it's
carry
an
analog.
It will carry analog signal, right? So that is the answer here. Okay. So
Sir,
when you,
but
yes,
in our network, we are always transmitting digital data over optical link.
so that is being converted, right? But now tell me, so if you have an optical fiber cable, inside that optical fiber cable, what is passing through? I mean, what is being passed? A light, an LED, or a laser?
Laser.
Laser. What is that? That is an analog signal. That is an analog signal. You can perform conversion, but
Okay, I got clarity, sir. Our signal is digital, our data is digital, but it carry in analog signal.
right. Exactly.
Okay. I understand.
Okay. All right. Great. So what do we have? We've got two types of signals. Okay. We've got two types of signals. One is a digital signal, one is an analog signal. So what kind of signals do we work with in this year? We work with digital and analog. Digital is understood by machines. Okay. And your media, okay, when you talk about media, your media could be cables. What kind of cables? Your media could be an optical cable. Your media could be a copper cable. Okay. Or if you are communicating wirelessly, then you've got what? Frequencies. Am I right? You've got frequencies through which signals are traveling. Yes or no? Is that right? Is that right, everyone? Okay. So basically, How many signals do we have? We've got two broad categories. One is digital. The other one is analog. All right. So in analog, you can have frequencies. Bluetooth works on frequency. Wireless networks, Wi-Fi works on frequencies, right? Then what else can you have? You can have light signals, or you can have electrical signals. And in digital, what will you have? You will have simple zeros and ones. So I hope this is clear to everyone now. The reason we had this discussion was to make sure that should be clear to everyone now. Okay. In digital, you will find bits, zeros and ones, and in analog, you have frequency, light, or electrical signals. Now, obviously, what Srirang mentioned, we've got SDH devices, but that is something that we will talk about in the upcoming classes. Since we are starting from scratch, so a lot of students might not know what this means. Okay, they do not have an idea about what this is. So what happens in this year? Okay, what happens in this year is you've got devices talking to each other. Now, I believe a lot of you would be wondering, why have I created two physical layers, one on the left side, one on the right side? Any idea for that? Yes, you can now unmute
Sender,
yourself.
receiver.
Sender
One
and
is sender and another is receiver.
Yes, sir.
Okay.
Source and destination.
Source and destination, right? Now, obviously, in a real world scenarios, you will not just have two parties, you can have multiple parties and they can talk to each other. So in order to explain this model in the simplest manner, that is the reason why I am using just two parties, sender and a receiver. So what happens is, let's say this is user one. User one is trying to talk to user two. All right, user one is trying to talk to user two. Now, what user one and user two think is that they're talking to each other directly. However, that is not the case. It just seems that they're talking to each other directly. So we can explain the whole communication process through OSI model. How? Both of them are working on a program or an application. Let's say me and Abhishek are talking to each other, right? So which application will be used? We will use Zoom. Is that right? We will use this application called Zoom. So according to us, what we are doing is we are just using Zoom application and we are connected to each other directly. However, that is not the case. There are other entities involved as well. So basically, both of us are sitting on the application layer. Now, if I say something to Abhishek, what is going to happen? Data is going to travel from application layer all the way down to the physical layer. So you will have app, presentation, session, transport, network, data link, and finally physical. And then it will travel all the way to the destination, to the receiver's end. Okay. So this would be their physical layer. So from the sender side, the data is traveling from application all the way to the physical, and from on the receiver side, the data will travel from physical all the way to the application layer. So that is how it is going to work. Understood? Now there are two things that I want to talk about here. Number one is abstraction. So this is not just limited to physical layer, this is limited to every layer. Now, can anyone tell me what abstraction is? Yes, unmuting all of you. What is abstraction?
Hiding the complexity, sir.
Hiding the what?
Complexity.
Okay. Any examples?
Sir, hiding unnecessary stuff.
All right. Any examples? That's what I'm asking for.
Like you are copying from one location to another. Windows is not showing the algos from C drive to D drive. It is hiding complexity.
All right. That's a great example. Any other examples like how about when you drive a car, and if you're not a car enthusiast, there are a lot of things happening in the background, right? I mean, behind the steering wheel, there are cables connected to a lot of other components in your car. I mean, so all you have to do is drive a car, right? You don't
Communication between devices.
what? Sorry, I could not hear you.
Communication between devices. Proper
Okay.
with medium and protocol. In the proper protocol.
No, but how is that abstraction? My question is abstraction. What is abstraction? I'll explain. Don't worry. So abstraction is like what is happening right now. Are you guys aware that we are not connected to each other directly? On Zoom, what is happening? There is a Zoom server. So when I am talking to you, my audio does not reach you directly. In between, there is a Zoom server, which is utilizing a protocol known as RTP, real-time transport protocol. Then when I send a message, a stream is created. Then that stream goes out to all of you. I know about this because I work on VoIP. Okay, I worked on VoIP.
That's
Right.
what I'm talking about. We need a medium to connect,
No,
and then we need a protocol to talk with our sender side and receiver side.
No, that is not what it means. You're talking about a different thing. Okay, I'll explain. Don't worry. So what I'm saying is, in between there is all this happening, right? My question is, should we be concerned about it? Should we be concerned about it? Yes, guys, girls. No, right? Because
No.
as long as communication is happening, we are talking to each other, we are good to go, right? I don't want to get into those nitty-gritty details. That's what I'm trying to tell you. Now, if any of these nitty-gritty details they get a fault in them, they get a problem in them, then the communication will stop. So what I'm saying is there are a lot of things happening in the world. Abstraction means that you should know only that much information that is necessary for you, right? For example, you're not feeling well, you go to a doctor, the doctor gives you a pill. Now, you don't really need to find out. The doctor is qualified enough. They'll give you a pill. All you have to do is trust them, eat the pill, that's it. You don't have to figure out what is it going to do inside your body, which enzyme is it going to break, blah, blah, blah. So this is what abstraction is. So the biggest concept, one of the biggest concepts inside computer networking is that the end users don't care about what is happening, right? End users will work with applications. I will use this application, you will use this application. Okay, and we talk to each other. We don't care what happens in the background. So that is what abstraction is. And then my question, another question that I have for you guys is, let's say me and Aditya are talking to each other. Okay, the two of us are talking to each other. Now, when I send him a message through Zoom, hey, Aditya, how are you? Now, obviously, all of you know that this message, when it travels down all these layers, it is going to travel down all these layers, and then it is finally going to reach Aditya. Right now, okay, right now, when I type this message is going to be in plain English. But when it reaches the physical layer, it is going to be converted into a set of bits, zeros and ones. And when it gets transmitted, through a medium, whether a wireless medium or a wired medium, it will be converted into a signal, a light signal or an electrical signal, or it will travel in through frequencies. Now, during all this process, throughout all this process, my question is whether the meaning of this message would change or not.
No.
No, right?
No.
It won't. So these two terms that I'm about to write and I'm about to explain to you, they are relevant in computer networking as well as in programming. Okay, so there is a term called syntax and there is a term called semantics. Okay, so what does syntax mean? Now, let's say I have to talk to someone. I have to say, hey, how are you? Now I'm using a language which is English and it is supposed to be a universal language. What if I talk to someone and I use my native language to talk to them? Obviously, they might not understand that. Okay, they might not understand that. So syntax is basically a format. Okay. Syntax means how you write it or how you communicate. Now, syntax can change for different languages. But this statement, hey, how are you? Would its meaning change in different languages? The meaning would stay the same, right? What do you guys think? The meaning would always stay the same.
Yes, sir.
Right? So semantics is the meaning associated with something. So in OSI model, what happens is every layer perceives data in its own manner. Okay, they try to understand data. They try to understand the messages sent by one user to the other user in their own manner. Okay, so in the upcoming classes, in tomorrow's class or in the next class after that, we will be talking about data links layer and network layer. So as I just explained, that physical layer works with bits and signals. Data link layer works with a format called frames. Okay, and network layer deals with decimal numbers.
Packets.
Right, packets, and it deals with decimal numbers. Now, just to let you know that the meaning of data would never change. It's just that its syntax would change when it will travel across these layers. So I hope this concept is clear to all of you, the concept of abstraction and the concept of syntax and semantics. Is that clear to everyone?
Yes, sir.
This abstraction means the thing is that behind the application, what happened is called abstraction.
Yeah. So no, the thing is that there will be things happening in the background. We don't need to know about them.
Need to know about that thing. We only know that what actually message is.
Yes, that's it.
Okay.
So that is what abstraction is.
Okay.
Can you explain once more again related to the semantics?
Okay. All right. So Abhishek, what is your native language?
Malayalam.
Malayalam. Okay. So I speak Punjabi. So if I talk to you in Punjabi and you talk to me in Malayalam, so what are we talking about? We are just trying to ask each other how we are doing. Okay. So it's like me asking you in Punjabi how you are doing, and you asking me the same in Malayalam.
Okay.
Now at the end, the meaning is the same, right? We're trying to ask each other about our well-beings. Okay, about our well-being. So that's the meaning. Syntax is change in format. When I speak in Punjabi, the format would change. You will not be able to understand that format. So language is like a format, right? So syntax means that in terms of OSI model, syntax means that every layer, presentation, session, transport, network, data link, when they will work on data, okay, when they will work on data created by the user, they will convert it into a format so that they can understand it and they can work upon it, right? That's called syntax. Every layer will add its own format, which means every layer will have its own syntax of working with it. But would the meaning change of that data? No. So that's called semantics. So I hope it is clear now.
Okay, I understood. Syntax means a set of rules, we can say.
Yeah, syntax set of rules, because in programming languages, that is how it works. So we usually call syntax as a set of rules in programming languages. So yeah, we can consider syntax as a set of rules. Exactly. Or you could consider it to be a format as well, right? A specific format.
Understood.
Got it? Yeah. And semantics is the meaning. Meaning would never change.
Okay.
Right? Okay. So I hope this point is clear to all of you, and everyone now understood the meaning behind this diagram. So what do we have here? We have two layers. We have actually dealing with the physical layer. This is on the sender's end. This is on the receiver's end. Okay. So here data is coming from the top, from the application layer. And here data is going from the physical layer to data link layer, then to network layer, and then all the way to the top. Okay. So that is what it means. And in between, what do we have? We have a transmission medium. Okay, could be any transmission medium, could be a wired medium, could be a wireless medium. Understood? So if it's a wired medium, then we are dealing with cables. Okay. If it's a wireless medium, then we are dealing with frequencies. So that is the concept behind this diagram. All right. And now, yes, Srirang mentioned something called SDH. Okay, it's a great device, right? But the thing here is that I want you to give me a very simple answer. Now, at the physical layer, machines are working, right? Data is being understood in the form of zeros and ones. Okay, data is being understood in the form of zeros and ones. But when this data goes through the transmission medium does not understand what zeros and ones are. The transmission medium will convert it into a format that they can understand. So how is this conversion actually carried out? From digital to analog, and on the receiver's end, analog to digital. Yes, write it down in the chat box. What do you think? No? Not really. That would not be the right answer. The router is not supposed to do that. That's not a router's responsibility. No, Shaleen. Nick is different. No? Nick wouldn't do that. No ICs, no switch. The answer here is what? The answer is modem. Do you agree with me? This is done by a modem. Okay, I'll repeat the question. When data has to be converted, okay, when data has to be converted from digital format to analog format on the sender's end, and on the receiver's end, it has to be converted from analog back to digital. Okay, so which device performs this? Which device performs this translation? Yes. What does everyone think about the device that will work here? Which device will perform this task? A modem. All right, a modem is going to perform this task. Now, some of you mentioned router. Basically, in the previous session, I explained one thing. I don't know how many of you attended that session, but I explained something that the router that you have at your home is very different from the router that you will have in your enterprise. Okay, the router that you have at your home is different from the router that are working in the enterprises. Do you guys remember that, when we were little, when we were kids, a lot of people used to mention that we've got modems at our home, and now the same device is being referred to as a router. Doesn't that create confusion? Right? Earlier, they used to say that those devices are modems. Okay, and now they say that these devices are wireless routers. So yes, others, what is your doubt? Tell me.
Sir, I have doubt between router and modem.
Yeah, I'll explain. That's right, don't worry. So modem is basically the device. Okay, modem is basically the device that is responsible for conversion of what? Yes, Srirang, you're right. But here people don't know about what transducer is. You work in that domain, people don't. Okay, so that's why I'm using modem first, because modem is something that everyone can relate to. I hope you understand why I'm using modem, not transducer right now, why I'm not using that term right now. Do you understand that? Okay, because I know what transducer is, you know what transducer is. Not a lot of people here know what transducer is. So they can understand through the concept of modem. Now, a modem is what? Okay, I'll explain, Uncle, don't worry. The transmission is transmission analog while transferring digital data on the devices, on your PCs, on your devices. What is the data format? The data format is a digital signal. And when it goes through the cable, okay, when it goes through the cable or when it goes through a wireless medium, it is at that time converted into what? Converted into analog. Understood? So as soon as you get it on the other device, when that is received, when that information is received, that information on your device is now in the form of what? Is now in the form of a digital signal. So basically at our homes, the devices that we have, we refer to them as wireless routers. What do we refer to them as? We refer to them as wireless routers. Now it's a box. So if your ISP is Airtel, then in a lot of cases you get a Nokia wireless router. Okay, a Nokia wireless router. right? Now, in your wireless routers, there are multiple components because it is wireless. Okay, because it is wireless, you are able to access Wi-Fi. So there is a small component present inside it called AP, access point. What is it? AP. Now, when you turn on your phone and you switch on Wi-Fi, you will see wireless connections nearby. Do you or you don't? You see wireless connections nearby. You see Wi-Fi nearby. Is that the right word to say? Technically, it is not the right word. Technically, we call it an access point. And the name of the Wi-Fi is known as SSID. So this name called silence of the LANs. Okay. It is known as SSID. Okay. So how do I get these names? This is the name of my Wi-Fi. Okay. So my wireless router, the router at my home, has an access point built inside it. And because of that, inside my home, I can get wireless connectivity. So that is one component. Then you have a router. You have a routing component or a routing module inside your wireless router. Now, what is a routing component? You are connected with me. You guys know that since you are connected with me, what is being used? The process of internetworking. What is internetworking? Communication between devices from different networks. I am sitting in my own network. You guys are sitting in your own home networks. So what is happening here? We are connected to each other. How is that possible? That is possible through a router. A router helps us connect to different networks. Understood? A router helps us connect to different networks. And yes, because of your ISP, because that router that we got is because of an ISP connection. It's because of an internet connection that we bought from our ISP. You're right, Super. Okay. So is that much clear to everyone? Why do we have an access point component and why do we have a routing component? Now, inside your home, you can play network games. Yes, Abhishek, what is the question? Tell me.
Okay, actually, I have a doubt that you told that from the NIC card we are getting the digital signals only, right?
No. I never said that from NIC card we are getting digital signals.
So, but when we say the NIC card converts the digital to analog,
no, NIC doesn't. That, okay. Modem does. Modem does.
So usually we connect Ethernet cable at the NIC card. Then how the data transmits through the NIC card?
See, NIC card is what? You have an interface. Correct. Okay, your device is going to have an interface. 8-pin interface, which is called the Ethernet interface, the Ethernet port. Mm-hmm. Right. And these days we don't really work with what? We don't really work with wired connections. So let's take an example of your router. Let's take an example of your wireless router. Understood? Now, what is going to happen? Your wireless NIC, obviously NIC is going to be used, and I'm sorry, I did not use that. What is NIC? NIC is the interface card for that particular interface. So if you are using Wi-Fi, you have a wireless interface. Correct. Okay. You have a wireless interface. So what is going to happen? Your wireless module, your wireless component inside your computer, when it works with digital data, it is going to convert that digital data into analog, and it is going to send that analog data to your wireless router. Okay. It is going to send to your wireless router. And then your wireless router, based on what kind of wireless router you are using, if the connection is a fiber connection or if the connection is a copper connection, an Ethernet, copper Ethernet connection, what is going to happen at that time? it is going to be translated into a light signal if you are using a fiber connection. So that is what is going to happen.
Okay. So, but the modem comes after a NIC, right?
Yes, yes.
So the conversion happens at the system end itself, right? In that case.
Right, right. If you're talking about the system, then yes, your NIC will perform that conversion.
Yeah.
And yeah, so it's going to modulate and demodulate the signals. So yes,
Correct.
that is what it is going to do. Yeah.
Okay.
I'm sorry.
Yeah, that was my doubt. Okay.
Yeah, I misunderstood your question. I thought that we were just talking about NIC. So yeah,
Okay.
my bad. Yeah.
Okay.
Sorry.
Thank you.
Okay, no worries. All right. So inside your wireless router, I talked about an AP, I talked about a routing component. Then you have a switching component as well. So if you're playing local games inside your network, you and your family members on their laptops, they are playing games within the network. So communication within the network is happening through a switch. Communication within the network is happening through a switch. Okay. And then you have a modem component. So what does modem component do? It takes the signals, it is going to take the signals and it is going to convert them. Digital to analog, analog to digital. That is what it is going to do. Okay. And along with that, you have a security component inside your wireless router. Okay. Like you can set up small security policies. You can decide, you can choose to decide which IP should work, which IP should not, which MAC address should be blocked, which MAC address should be allowed. So basically, modem is a component inside this device. Clear? Is that clear to all of you now? So this is the difference. Understood, everyone? Any doubts related to this? Yes, you can unmute yourself. So any doubts related to this that I've explained?
No, sir.
No, no doubts. Okay. All right. All right, Pratmesh, I'm going to
Sir,
summarize.
modem is within wireless router.
Yes, modem is within wireless router. You will not really, these days, you will not really keep a dedicated or an independent router. Okay. That does not make sense.
So this AP switching, routing, everything is happening within a wireless router,
Within your wireless router.
and it includes modem also.
Yes. Okay. And for
Okay,
your
sir.
devices and for your devices, for your computers, that is where NIC will come into play. So when Abhishek asked me a question, I thought that he was asking me a question just related to conversion that happens in this case, conversion that happens in this case. But on your at a device level, NIC comes into play. So a lot of you still don't know what NIC is, and we are going to talk about NIC in the next layer, which is the data links layer. Okay. All right. So that is how it is going to work. So if I summarize this, this is the data links here, and what is happening here? We deal with different data formats. We deal with digital signals. We deal with electrical signal. We deal with analog signals. Okay. So analog signals can either be electrical, they can either be light, they can either be electrical or light, or they could also be in the form of frequencies, right? That is what it means. And then I explained how a wireless router at your home is different from the routers that you use in the enterprises. Understood? So that is what the physical layer is. So I hope everyone got the gist now.
Yes.
Right? Everyone got the gist of what this layer does. Now, let's talk about the functions. Okay. Then let's talk about the functions of this layer. Right? So the first function is bit synchronization, a very simple and easy to understand function. So this is your application layer. This is your physical layer. I'm skipping the rest of the layers because it will take time to write them. Okay, so application. Physical. So communication is going to happen. Right, communication is going to happen. So let's say I am user 1 and there is user 2 on the other end. Now I send a message. Okay, I send a message. Hey, how are you? Now, obviously, through the concept of syntax and semantics, we are sure that at the physical layer, we will get the exact translation of this message, but in bits. So let's take an example. Let's take a small example that the value gets converted into 0, 1, 0, 1, 1, 0. This is not the right value. There are ASCII to binary converters. Okay, there are English language to binary converters. So I'm just taking a small example. This is not the right value. This is just a dummy value that I'm taking. Now, what is going to happen if we don't have a physical layer? Okay, if we don't have physical layer in the OSI model, if we don't have a physical layer working, what would happen? It is possible that the bits, when the bits are getting converted into electrical signals, some fault occurs, some error occurs. And on the other end, the bits that you get them are in this format. 1, 0, 1, 1, 1, 0. Okay. And another 0. This is what we get. 1, 0, 1, 1, 0, 0. Now, as you can see, we've got 3 zeros and 3 ones. So nothing has changed. But one thing has changed, and that is the order. That is the order of the bits. Now, when the order of the bits would change, will I get the same message or will I get a different message? Yes, that's my question for all of you. Will I get the same message or will I get a different message? We'll get a different message, an altogether different message. So why did this happen? Because there was no synchronization. There was no synchronization. So at the physical layer, okay, at the physical layer, what happens is bit synchronization. Now, every device has something called a clock. You know that our computers have clocks. And what would a clock do? Okay, I'm muting all of you. What would a clock do? What do you think?
Keep everyone at same time.
Okay, everyone as in like
Um,
who's included in everyone?
Clock speed is the type of
Clock speed is a nice concept, yes. What else does a clock do? So I'll tell you, clock is inside your CPU. What will a clock do?
synchronize every
Clock
party on the network.
Sir, clock maintain frequency of data transmission so that every data transmitted in actual time, and DoD is maintaining this atomic clock to maintain the data.
number of instructions it processes, the bandwidth, and the clock speed.
Okay. All right.
Sync the data according to the real-time stream, like
Okay,
MPP.
Yes, we will sync data in real time. And what about our CPU clocks? Like, that's the only question that I'm asking you guys. I want a simple and crisp answer. Is it just for checking time? Is it because of our device clocks that we get correct time on our PC? Or is there a different function performed by our device clock?
Sir, there is an atomic clock from every we get from DoD in
What is
America, and
uh-huh,
Department of Defense.
right?
They will keep checking on this,
Thank
and
you.
they will. They are master, and we get master point of GPS clock or atomic clock. So we will keep the frequency checked, and these frequency will maintain the data to respond at the same time.
Okay, that's right.
Clock triggers transmission only when the other device is ready to accept.
Right. So I think everyone is right here. So I just asked a simple question, guys. I didn't want, answer in this much detail, but hats off. Yeah, you guys gave perfectly correct answers. The only incorrect answer here is that it's not just used for checking time. So a device clock basically syncs all the components inside your computer. Who's the brain of your computer? A CPU. So a CPU is supposed to make sure that every component inside your computer is synced to that clock. Okay. And then, yes, like Zubair mentioned, it is responsible for clock speed. Then Srirang mentioned that, yes, there is an atomic clock maintained by DoD, and then the concept of strata would come when we discuss NTP. So everyone was right. So basically what physical layer does is, it will, and yes, what Adil mentioned is when the other device is ready, it will send the data. That is also correct. So bit synchronization is a function of physical layer, and what it does with this function, it synchronizes both the sender and the receiver. And it will send the data, obviously at bit level, by synchronizing both sender and receiver. So there are different types of transmission that we'll talk about tomorrow. There is serial transmission, there is parallel transmission. Okay. So those concepts will come into play and they will help you understand bit synchronization better. Okay. So this is where we will stop today. We'll carry on the functions of physical layer tomorrow. Okay. So before we end the class, I'm going to give a quiz to all of you. This quiz is just to test you. It's just to test how much you already know. Okay, how much you already know. So I will create a WhatsApp group tomorrow. Okay, I'm going to create a WhatsApp group tomorrow. Don't worry. So let me go to my other account. So I have a quiz for all of you. So this quiz applies to CCNA as well as a certification called Network Plus, right? So all that I'm trying to do here is just find out how much you already know about computer networking. So it's not that, if you get less marks, you will not be allowed to sit in the classes, nothing like that. Just to find out how much you already know and how will I arrange my pace. Okay. How will I organize my pace for this course? Do I need to take the course slow? Do I need to take it fast? Okay. So this is what is going to help me out with. Okay. So Prasun, don't worry. Tomorrow I'm going to walk everyone through the course portal. Okay. I'm going to walk everyone through the course portal. So far, this is our second class. Okay. This is just our second class. All right. So we'll meet tomorrow. We'll take this further. I'll keep you unmuted for the whole session tomorrow. We can talk, we can interact. Okay. So yeah. So that would be all. Thank you. Bye-bye and take care. See you tomorrow, everyone. Bye-bye.